All right, so the next topic that we're going to be looking at is quadratic equations, okay, and something called a parabola. So we earlier this year looked at a whole bunch of things called linear equations. We didn't call them that too much, but we did bring up that word linear a few times, okay, and linear equations, right, has that root word line in it. So when we graphed these equations, we would find that when we graphed them, they'd look something like that. It always made a straight line. Okay, well now we're going to look at a different kind of equation. Instead of having equations that always just had a regular x, or maybe it would have like a 3x or something, a number in front of the x, but it was always just a regular x. Now we're going to start looking at equations where instead of a regular x, it's going to be an x squared every time. And maybe there'll be a number in front, maybe there won't be, but it's always going to be an x squared. Okay, and now these graphs, where before we had graphs that always made a straight line, quadratic equations, their graphs always make a special shape called a parabola, which looks an awful lot like a U. Okay, so that's what we're going to start talking about today. Okay, so we're just talking about the introduction to what a parabola is. Okay, so the first thing that we have is that a quadratic equation makes a special shape called a parabola. Okay, and then this is a typo. It should say the graph of a parabola is always symmetrical. Okay, so symmetrical, if you don't remember what that word means, symmetrical means it's the same on both sides. Like you could put a mirror in the middle and it would show the same thing on both sides. Okay, so that's what symmetrical means. So when you kind of look at this graph, you can see that it looks symmetrical, right? If I put this half here and I were to just take that half and flip it over, you'd get the other half. That's what symmetrical is. Okay, so this is the general shape of what they look like. All right, and if we think about what our table of values is for this equation, y equals x squared, right? I'm going to kind of set this up. I'm going to put 0 in the middle, and then 1, 2, 3, and -1, -2, -3. Well, when I plug these in for x, -3 squared is +9, -2 squared is +4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9. So when you look at your y values, you notice here, there's where you can see your symmetry, right? It's the same on either side of the 0 going in both directions. If you kind of folded this list down, it would all match up. That's what symmetrical means, okay? So that's what we have for this graph here. All right, now, parabolas have key features that you're going to need to know about. Okay, so the first thing is the vertex. Okay, so the vertex of the parabola, okay, that is always either the highest or the lowest point on your graph. So for this particular example right here, this point, that is your vertex. It's the lowest point on the graph. Okay, so when your graph looks like a U shape like this, you're going to have a lowest point. Okay, but sometimes you're going to see that these graphs will get flipped, and we'll talk about how that happens later. But like if you look at this example down the bottom, you can see this one is the same shape, but it's been flipped upside down. Okay, well, when that happens, then instead of having a lowest point like we do here, now this guy is going to have a highest point. Okay, so your vertex is the highest or lowest point. Okay, if it's the lowest point, like this guy, okay, then that is called the minimum. So that's when you have a lowest point. And if it's the highest point, like on this graph down the bottom, that's the highest point, then we call that a maximum. So that's when it's the highest point. Okay, so your parabola is always going to have either a lowest point or a highest point. It can't have both. All right, and then the other things that we have, the next thing we've got is something called an x-intercept. We've talked about these before. Okay, so the x-intercepts are any points where the graph crosses the x-axis. So any points where the graph crosses the x-axis. Okay, and remember the x-axis is the sideways one. All right, and then y-intercepts, which again, we've talked about those before. Y-intercepts are any points which there's only ever going to be one of these. X-intercepts, you could have no x-intercepts. You could have one x-intercept like this guy, right? It only crosses that x-axis once. Or you could have two. Okay, so you could have 0, 1, or 2 x-intercepts, but the y-intercepts, there's only ever going to be one. Okay, so that's going to be the point where the graph crosses the y-axis. That's why we call it a y-intercept. Remember, that's the up and down one. Okay, so these are kind of the key features that you're going to need to know. So let's take a look at this graph down here, and we'll kind of see this in action a little bit more. Okay, so the first thing that we need to find is the vertex, and we're going to find the coordinates of this point. So the vertex, remember, is always either the highest or lowest point. So that's this guy here. This graph, even though there's not arrows on here, this graph goes on forever in this direction. Okay, so it's always going to be getting smaller, but it never gets bigger than here. So that point right there, that's called my vertex. Okay, and the coordinates to that point, remember, you run and then jump like Mario. So that's -1, 5, 6, 7, 8. So my point is -1, 8. That's my vertex. Okay, now the next thing that we want to know is that a minimum or a maximum? Okay, minimum, that's like the smallest, like the minimum volume on something is really small, right? The maximum volume is really high. So this is the highest point, so this guy's a maximum. So you just have to identify that it's a maximum and not a minimum. All right, next, my x-intercepts. So x-intercepts are where you cross the x-axis, the sideways one. So for this particular graph, I have 2 of those 2 points right here. Okay, and remember, we run and then jump. So this point right here, that's -1, -2, -3. So that's run to -3, jump to 0. This guy, I'm running to +1 and I'm jumping to 0. So there's 2 x-intercepts there. And again, you can have 1 x-intercept or 2 x-intercepts or no x-intercepts. It's possible. Okay. And then the last thing is the y-intercept. That's where your graph crosses the y-axis. So here's my y-axis, and here's the point where it crosses. Coordinates to that point, remember, you run and then jump. So I'm running to 0, and then I'm jumping to 6. So the coordinates to that point are 0, 6. Okay, so this is just some basics about what a parabola is and what the key features of the graph are. We're going to do a bunch of stuff with these. The key thing with parabolas that makes them kind of important is that they model a lot of different things. So when you have like a satellite dish is like if you took a parabola that was like a really like flat, skinny one and you spun it around, that's the shape that like a satellite dish is. And that's how satellite dishes work. When your speakers, if you've ever taken apart like a speaker or even maybe a headphone, they have this like metal like cone thing inside. That's a parabola. Okay. And that's how the sound gets sent out. If you've ever looked inside of a flashlight and the head of a flashlight where the light bulb is, there's that metal like cone shape. That's a parabola. Okay. And that's how flashlights send out really strong light or really weak light, depending on how good they are. Okay. So it's a really, really helpful shape. And then the other thing is that anything that goes up and comes down follows the shape of a parabola. So like if you shoot a rocket up into the air in your science class, that's going to follow the shape of a parabola, right? It goes up and then it turns around and it comes back down. Okay, if you kick a soccer ball or if you jump or anything like that, that follows the shape of a parabola. Okay, so that's why these guys are really important. So the big thing that we're going to focus on in this class, just because we have so little time because of remote learning, is we're going to focus on finding these points here. Okay, because like I said, parabolas model things that go up and then come back down. So if we can find these 2 points, we can say, oh, well, I know that this rocket took off from -3 and then it landed over at 1. So that means it went 4 feet, if you will. Okay, so this is kind of a weird example, but you can look at things like that and see, well, how far apart is this thing going to go? Which is useful if you're, say, trying to hit a target. Okay, So that's going to be kind of the key point that we're going to focus on just because we have so little time. So we're going to really focus on how do we find these 2 points right here. Okay, but not today. We'll do that on another day. Today, you need to be able to just find these key features when you're looking at a graph and understand what they are.